definitely if you are like Web3 developer, uh, I know that like a lot of the focus has been on like, maybe like understanding, like just like writing smart contract or like using some libraries and so on, right? But I think having more understanding of how the underlying blockchain works, especially the runtime part, is quite beneficial.
Hello and welcome to another episode of Devs Do Something. Today's guest is Bowen Wang, who is the head of protocol development at Near. So this episode will serve as a technical introduction to Near protocol from the point of view of an EVM dev. So Bowen and I discussed a lot of the inner workings of Near, including things like sharding, asynchronicity on Near, JavaScript smart contracts, which I find to be an interesting concept, especially for you that either have a very strong positive or negative opinion of JavaScript. And then we also go into things like Near's human readable name system and how that's actually works. It's actually built into the protocol, which I found interesting. And then we walk through some of Near's analogues for account abstraction, right? So UX is huge. Near's really focused on it. And I think it's interesting to hear how someone that's working on the protocol side is viewing this and trying to build a roadmap around this. We also discussed how Aurora works, which is an EVM compatible scaling solution built on top of Near. And I think overall, if you're interested in broadening your horizons beyond the EVM and understanding how another protocol works at the lowest levels, this episode's for you. The last thing I'll say is that Bowen is a great engineer himself, and he had a lot of good advice, especially at the end of the episode, that's more general advice for Web3 devs that I think a lot of you might get some things out of, right? So he talks through maybe some bad advice he hears given in the space to early career devs, and then how he'd go about trying to level up as a dev himself if he were just starting today. So hopefully this episode broadens your knowledge base to other L1s. Hopefully it gives you some education on how maybe Aurora works and gives you some ideas for maybe the things either you want to propose in future ERCs or EIPs into the Ethereum, or building scaling solutions of your own. So again, sit back, enjoy the episode, and let us know what you think. As devs, we all love hackathons. They're a great way to boost your skill set, meet other engineers, and add to your portfolio of work. At Superfluid, we've sponsored many hackathons and decided to start putting on a hackathon of our own, the Superfluid Wave Pool. This hackathon is a little bit different though in that it's continuous, it's always open. You can submit any project built on Superfluid at any point throughout the month and have a chance to earn thousands of dollars in prizes depending on how your project stacks up. In just the last couple of months, we've seen dozens of teams build really amazing projects that run the gamut from Superfluid developer tutorials to full-fledged applications to a proof of concept Superfluid StarkNet implementation that we thought was really, really impressive. So we encourage you to check it out today. You can learn more by going to superfluid.finance/wavepool. That's superfluid.finance/wavepool. Happy hacking. All right, we're here today with Bowen from Near. Welcome, Bowen.
Hey, hi everyone. Very happy to be here.
Yes, it's great to be chatting with you. I'm glad we got connected. And this is exciting because this is one of the first episodes. We'll do another one with someone from the Solana ecosystem soon, but it's one of the first episodes where we kind of branch out beyond the pure EVM and dive into other ecosystems and how they work. So we're very excited to deep dive Near. Bowen, you are the head of protocol development in Near, right? Fantastic. Now, we're going to get into Near. We're going to get into like how to think about Near when you come from the EVM perspective. But before we do that, the first thing we always ask guests when they come on is how they got involved in the industry. So I'd love to hear how you got into crypto.
Yeah, it's actually a very funny story. So Near was not a crypto company at the very beginning. So before crypto, Near was actually working on machine learning and more specifically, what's called neural program synthesis. What it does is essentially like teaching machines how to write code. So I know that ChatGPT is all the rage these days, and it's essentially like what we were trying to do back then was basically part of the functionality that ChatGPT has today, which is like if you gave it natural language description of like, let's say, a program or like a piece of software that you want to write, then it will try to generate the code for you. Obviously, for 5 years ago, technology was not as mature as it is today. So that was very ambitious, but I think, yeah, we were just running into like practicality problems. And then it was actually interesting that our co-founder Alex was looking at what kind of applications this could be useful for, right? And then smart contract um, kind of was like one thing that they were looking at. And I think part of the reason is that smart contract is really like a piece of pretty self-contained software, and then you don't have, you really don't have like a smart contract that's 10,000 lines of code, right? It's like usually 700 lines of code, that kind of thing. So yeah, it's just like looking at, well, how can we apply this to writing smart contracts? And to do that, you first need to understand the smart contract. Then that's how got into blockchain. And then, yeah, I think at some point they realized that, well, the existing smart contract platforms at the time were not as good as they could be. So yeah, I was just thinking about how to what what could we do to design like a better system, both on the kind of blockchain or just like more like the fundamental protocol level, now, as well as like how to make it easy for people to write smart contract. That's how Near got started.
I love it. Yeah, that's actually fascinating. I had no idea that was kind of the genesis of what the Near team first started working on. I'm always fascinated by pivots like that, and I think it's cool you ended up doing something totally different. How do you think that Codex and OpenAI are doing so far with the machine generated code? Do you use a Copilot or anything like that?
I mean, kind of tried it, but I think, yeah, ChatGPT is definitely very impressive. Like what it has been able to do is essentially like, yeah, that's as I said, like what we were trying to do back then. So I would say, yeah, very impressive.
Good. Yeah, no, I'm excited for what that's gonna open up. At minimum, it can help remove the job of writing some boilerplate for us. So hopefully that continues to mature.
Yeah, actually, a funny story. One of my colleagues tried something like write the basically the input to ChatGPT is like write a Discord bot that would be able to um, I forgot what exactly it is, but like connect to Near in some way, and it actually was able to generate like a piece of code that does that.
I know it's very impressive. I've run similar
Yeah,
experiments, like transfer a token on Polygon, and it generates
yeah,
the code, right? Which is interesting. Simple things like that it seems to be able to do. Obviously, like brand new
yeah,
problem solving is a bit different, but yeah, no, it's
right,
definitely
right.
fascinating. But shifting the topic to Near a bit. So we were talking off camera about our audience so far, and I mentioned that most people, I think, that listen to the podcast are starting to experiment with different environments, different programming languages. But most people are kind of used to the EVM mental models, right? They're used to the Ethereum virtual machine. They're used to building in Solidity and things like that. So before we really kind of deep dive some of the specifics of Near, building on Near, like what mental models in particular are very different for someone coming to Near and looking to build on Near from the EVM? Like what are the big couple of things that they'll have to wrap their brains around?
Yeah, so I think mainly two things, right? One is on the more maybe programming languages level or like the actual development itself, right? And then the second one is on the um, execution model or like runtime. So on the first one, usually if you target EVM today, you're writing likely in Solidity, even though there's some other languages also support compilation to EVM bytecode. Most people today probably write some Solidity, right? So Solidity is like a programming language that has some similarity, or like it's mostly bears similarity with JavaScript rather than Rust. So if you come from that background, um, compared to Near, then I think that is maybe like one of the big. I don't know how much of like a mental shift that would be, but definitely a big change. So Near today also support JavaScript. I mean, we can talk more about that later. So I think that's definitely a easier way for people to get onboarded. And then the second one is that if you target EVM, the execution environment is likely synchronous. Let's just use Ethereum as an example, right? You can do things like flash loans, and you can just call like different smart contracts in one function call, and the execution would all be synchronous. And now Near, the execution model is fundamentally asynchronous, and that is definitely quite different. So if you're writing like a single application, like kind of like standalone application, doesn't really matter, kind of the same. But if you're writing um, things that application that needs to compose with each other, the model definitely would change, right? If you're a DeFi developer, there I think the assumptions needs to change, and how you handle failures of function calls needs to also change. I think those two are the um, biggest difference I see.
Interesting. Well, I mean, I think people can pretty easily understand like the just writing a smart contract in a different language, and I think that's somewhat straightforward,
Yeah.
right? And I think most people that build on the EVM, they probably know JavaScript, unless they're a rebel and use like Brownie and Python and Viper. Um, but okay, I think what you're saying though on the second part is that you're I think you're alluding to the fact that the model for transactions is a bit different, right? So there's this
Yep.
concept of like asynchronous transactions, which I think is kind of fascinating. But I think it might be good to just go through like, all right, contracts that compose with other contracts are going to be different. You have to handle like failure cases differently. There are actions and there are receipts, right? Can you walk
Mhm.
through like just what a standard transaction would look like on you? Like, can we walk through like what a standard token transfer
Yep.
might look like?
Yep. Absolutely. So a token transfer is actually slightly different from a function call, right? So let's say like you were sending, so Alice wants to send 1 year to Bob. So Alice signs the transaction, and then it sends to some like validator, and then the validator include that transaction in a chunk that they produce, and then through consensus, a block is produced that contains the chunk, and then when the chunk is executed, um, it first, first of all, the chunk we're talking about here is the chunk for Alice shard. So the transaction execution always starts in the shard of the sender. So when that transaction executes here, what it does is that it will charge for the gas, deduct that from the sender's account, and it will also debit the sender's account because you're doing a token transfer. So Alice account would now have 1 year less. And then after that is done, what happens is that a receipt is generated and it's going to be sent to Bob's shard. So how exactly that works is that each shard would, in kind of the output of the transaction execution, it will generate this kind of outgoing receipt. And the outgoing receipt will also be Merkleized, and this Merkle root would be included in the next chunk. And there's like a separate mechanism for the kind of validators in different shards to request the receipt from other shards that's coming to this shard, so that they know what to execute. And they can also verify that but through the receipt root that's included in the next chunk for the other shard, so that they know that this is authentic information. And then after that receipt is sent to the other shard, it would execute there, and then Bob's account would get 1 year, and then the transaction would complete.
Got you. Yeah, and that's one big thing to keep in mind as well. I think for people listening is that you're making heavy use of parallelizing different like actual operations, right? That's what
Yep.
that's what sharding is actually doing. So
Yep. Yep.
again, maybe it's best to zoom out. Well, then we'll come back into the token transfer bit, and then ultimately like the cross contract transactions. But sharding, what's the role of sharding here within Near?
I think it's quite fundamental, right? So one of the core premises of Near is that we want to build a highly scalable system. And as you probably know, scalability has been like a big concern in the blockchain industry, right? A lot of people complaining about the low transaction throughput of Ethereum. And then Ethereum itself is moving to like a more kind of sharded design, even though they're taking like some, whether like of a different path. But for Near, we're basically building sharding into the protocol so that both the transaction processing and the state are both sharded. So in this design, the throughput of the system should be roughly linearly scalable with the number of shards we have.
Right. And that should, in an ideal world, massively increase speed and throughput, right?
Yep.
So on the transaction itself, is the asynchronicity, is that something that is necessary given sharding, or is that an extra, I guess, feature that's separate beyond sharding?
That's a very good question. So I think it is necessary at some point, right? So you can do kind of like synchronous sharding to some extent, but I think the difficulty is that, at least my opinion is that if you want to scale beyond some point, synchronous sharding becomes very difficult just because of the need to get like data in one place in order for you to kind of execute everything synchronously, right? So we actually have done some research on that front as well. So the idea is that if we want to think about how it like, and obviously we're talking about here still we want to shard like kind of state and transaction, right? Obviously, if you don't want to shard state, then it becomes easier. If you just shard transaction processing, then I think that's definitely a separate question. Like if you still want to do both, then like essentially what you're trying to do is that you're trying to find some mechanism where you're trying to kind of aggregate the state on the fly while you're like essentially like you guys, or let me take a step back. Like what you're trying to do is that let's say you have like a block, right? You have some kind of transactions you want to execute. And in order to execute that, what you're trying to do is that you're actually aggregating all the state that thing needs across all the shards. There needs to be like a step where you do that and then you execute. So that step is actually quite non-trivial if you actually scale up to like a very large extent, right? Because you need to figure out, well, like how do I actually get the relevant pieces of the state, and then how do I aggregate them together, and then like execute them, and then form consensus, and then move the chain forward. So at least in the research that we've done, we think that it is possible. But if you want to scale beyond, let's say, I don't know, like 1,000 shards, it definitely becomes less easy because of both what I just talked about and also the data variability stuff and so on. So at least in my opinion, if you actually want to have like really scalable system that would be able to handle, let's say, the Web2 applications that we see today, I feel like asynchronicity is almost required. And you can also see that from what other chains are doing, right? So if you look at how Ethereum is planning to scale, even though that's like a very different model, fundamentally they are adopting the asynchronicity in their thinking, their roadmap. Because even though like a layer, like scaling through layer 2 is different from the design that Near has, fundamentally you can view that as like a kind of changing the execution model from synchronous to asynchronous, right? Because even though within each rollup, your execution is synchronous, like you just do whatever you have on the base layer in terms of execution model. But then like you have the step where you have to move things between like the rollups, and then there you have no choice but to be asynchronous because and then if you do that, then you're essentially doing what Near does today, except that it's just done on like a in like layer 2, right? Kind of like outside of the protocol.
Interesting. That is a very, very interesting perspective on it. Um, and so as a developer though, like thinking through like, all right, how this works, like when a transaction actually happens, what I found that's interesting is that this receipt object, it's an object, right? It's actionable, right? Can you talk about like what this receipt is? Like when the transaction is actually confirmed, like what is this receipt? What can I do with it? It seems very similar to like working with asynchronous JavaScript, right? But would love to hear you talk about it.
Yeah,
Yeah.
yeah, yeah, yeah. Yeah, I think the mental model is similar, right? I think receipt is more like a protocol level construct that developers themselves don't need to worry a lot about. At least, that's our thinking, right? We want to reduce the cognitive barrier for developers as much as possible. So ideally, developers don't really need to think too hard about, how receipts work. The idea is that, after transactions are executed, they will generate receipt, and the receipt will be sent to the destination shard to execute. And then all of those are taken care of by the protocol itself, and developers pretty much don't need to worry about it. The only thing that developers need to care about is, let's say, you want to have like a function call that calls another smart contract, right? Then what it actually does is that it generates like a receipt that's going to be sent to the other shard where the smart contract is to get executed. And then it may and that execution will produce some result that will come back, and then the developer may need to handle that result as well. So yeah, in that sense, I think the model is similar to like async JavaScript as you described. But a lot of the heavy lifting is kind of done behind the scenes by the protocol.
Gotcha. So like what kind of like does the asynchronous aspect here open up other features and things that developers can build on Near that aren't possible in other places?
Yeah, I think it's mostly around the scalability aspect, right? And even if you think about um, async in like from like a programming language point of view, right? Async JavaScript and so on, it doesn't do anything that's not possible otherwise per se, right? What it does is like a better performance kind of thing, and that is, I think, similar here as well.
Gotcha. Yeah, I think that makes sense. So on you mentioned here specifically that these asynchronous transactions are the default when you make a smart contract to smart contract call, right? So
Uh-huh.
is this only the case if I'm like you mentioned in the example of like a token transfer? This doesn't happen, right? This asynchronicity is the asynchronicity there as well?
Oh, yeah, yeah. No, that's still async. So I guess the difference I was talking about is that in the smart contract execution, it would generate like a um, kind of like a different kind of receipt. But yeah, overall the execution model is still the same. Like even if like you're doing kind of a transfer or like function call within the same shard, the execution model is still the same. It's like it doesn't really care like whether you're calling something within the same shard or calling something outside of on another shard, because this would allow us to do like things like resharding, right? Because even though two accounts or two contracts can collocate at this given moment, maybe like in the future they would be resharding to different shards, so that you don't rely on this kind of information to execute transactions.
So how does this relate to like error handling and security for developers, right? I'm assuming that like
Yeah,
I
yeah.
saw someone in your doc, so like technically you can execute a transaction, but that receipt might do like they're actionable, right? So I might do something on receipt which might fail, right? So there are specific security concerns that developers need to understand when working within this new model.
Yeah, so one big difference is, let's say you're developing on Ethereum, right? Then you have like a smart contract. I don't know, for example, swap some like a token on like one DEX, and then you use the new token to borrow like some other token on like a lending protocol, and then you use that thing to do something else. For example, if it's like a complex chain of calls. And then this call in the Ethereum system, in the Ethereum world, it would either succeed or it would fail, right? And then if it fails, then everything reverts back. Um, but on Near it's actually different. On Near, if you call like another smart contract, and then that smart contract calls like another smart contract, then it may come back. Uh, you need to handle the case where like the call, uh, like some intermediate call fails. And it would revert that part of the call, but it wouldn't revert the entire thing because it's asynchronous. So you essentially you're like, it's kind of like JavaScript async await that you just need to handle like the callback. It's like the callback gives you some result. It's like either like it succeeded, returns some value, or like says, well, I run into an error. Like in the case of an error, you may need to like do something to like handle the error and revert some part of the state, for example.
Got you. Yeah, I think that would actually feel somewhat different for a lot of people coming into the Near ecosystem from Ethereum. I think that, especially people that are building in DeFi.
Yeah, I think, especially that, because if you're not building DeFi, it's actually quite similar, right? Because you don't really care about calling like 3 other contracts in the same.
For all the people that are doing crazy exotic flash loan things, that's different, right?
Yeah.
Okay, so let's tie this all the way back into our token transfer. So I kind of glossed over this, but when I said token transfer, you went to like I'm sending Near, right? And I think the way you describe like the Near token is that it is a token, right? Like someone would in Ethereum, you might describe like ETH as like a native asset, which kind of has different rules than these ERC20 token contracts. Is there like an ERC20 analog? Is there like an ERC20 analog on Near where like you can deploy a USDC contract? Are those like first class citizens? Because I know on some chains, like we did an interview with someone at Fuel, and like you can basically create your own native assets on Fuel. How does it work on Near?
Yeah, so on Near is actually quite similar to the Ethereum. So we have so the fungible tokens is its own standard, and it's right now not built into the protocol itself. I mean, that may change at some point in the future, but at least right now, it's very similar to how Ethereum works. And then Near token is special. It's like a native asset similar to Ethereum. So in that sense, the model is quite similar.
Got it. Okay, makes sense. Okay, so that all cleared up a lot for me actually, and I think it was interesting to talk through a lot of the async stuff there. Okay, so what about the Near account model? Right, I think there are a lot of interesting things here. Can we walk through like the basics of the account model, and then I'll ask some specific questions about things like human readable accounts and some other stuff?
Yeah, so Near's account model is definitely different from Ethereum's account model. So, well, one, it is still account based, right? So that in that sense, it's similar to Ethereum. It's not like UTXO based. But like the difference is that on Near, every contract is like an account, or like every account could be a contract, and every account you can have like 0 or 1 contract deployed on that account. That's what we have right now. In the future, maybe we can allow like multiple contracts to be deployed on the same account. But right now, it's like either you're just like regular account, or you have a contract deployed on the account. Right? And then if you have a contract deployed on the account, this is just like when people say like a contract, that's usually what they're referring to. But the thing here is that the kind of there's no real distinction on Near between like a account and contract, right? And then that gives rise to a lot of interesting stuff like contract-based account. Like you can use like a smart contract to manage your account. For example, 2FA that some wallets on Near has, it's basically like how it works is that you have like a multi-sig contract deployed on your account, and that allows you to do like a 2FA because you need like multiple keys to sign to make sure in order for the transaction to go through.
Yeah, I mean, what this is, and I think I saw you like maybe either respond to a tweet about this or something related, but all of this enables a lot of the account abstraction things that we're all up in arms and debating about on Ethereum right now.
Yep.
You have a smart contract wallet, right, which is kind of like step one to enable account abstraction. And then you have these things called like, you have these access keys, right? Can you walk us through like different access keys and what those enable?
Yeah, that's also one special thing about Near. So Near has 2 types of access key, right? One is called full access key. This is similar to any other so to like keys you have on any other blockchain. You have like full access to the account, and you just do whatever with the account you want, right? And then it has a special access key called function call access key. What this does is that it restricts access to certain method on the account, on the contract, right? So you can say like this key can only call this method on this contract. And so why is this useful, right? It's useful because you can actually give this function call access key to like an application to manage it for you, right? So for example, you want to use some application, but you don't want to authorize it every time. Then what you can do is that you generate like a function call access key. You say like this function call access key can only be used to call like some specific method in this contract, that is this application, and then this application now owns this access key. It can send transaction on your behalf, but it's actually fine because it can only call the method in that application itself. It cannot like transfer all like your tokens to some other account, and cannot like delete your account. It cannot do any of that. So this is like a way to dramatically improve like the user experience on Near, because you now essentially don't need to like authorize it every time you want to interact with this application. Like the application just send the transaction for you, like, and the user wouldn't even know. Like, they wouldn't have to go through the interface of like, signing like through wallet or whatever that is.
Yeah, so I actually, on a related note here, I had a conversation a couple of weeks ago with Julian, who's the founder of Argent. It's a wallet that's gotten some traction.
Yep.
He's a big proponent of account abstraction, like on some of the zero knowledge platforms and even Ethereum. And he mentioned that they've rolled out this feature called session keys within their smart contract wallet, where it's very similar to what you just described, right? Like they're gaining traction amongst like game developers, where you could allow someone to basically have access to just calling functions on your behalf for a certain amount of time, or just on a certain contract for a certain couple of functions. And it enables you to basically have a similar login experience like you're used to in Web 2, and then interact with the game, right? Maybe spend money, maybe like move tokens around, but it's confined, right? And it allows a developer to have kind of granular access over like what can this account do, and it even gives the user control over it as well, where you're not taking away self-custody necessarily, right? You have control over the wallet still, but you are enabling a potentially much, much, much better UX. So I think that's very cool. It's very cool. How about the human readable names? I find this interesting. So again, like this is another analog here, like ENS or the Solana's got their own thing. Is like the account is like the human readable accounts thing, is that built into the protocol itself?
Yeah, basically it's like EOS building to the protocol.
Very cool. How does that work exactly? Is there like I'm assuming there's no like registry contract. The registry happens at the protocol level. Can you walk us through how that works?
Yeah. So basically how it works is that you have those like top level accounts, right? So let's say Near is like a top level account. So those top level accounts can only be created by like a special account called registrar account. And then once you have those top level account, each top level account can create kind of like a sub account. I mean, sub account in the sense of like the account name, right? So the account name would be like Bowen.near, for example, or like Sam.near. So it's basically like a sub account on the namespace level. It doesn't actually have anything to do with like a permission control on the account level, right? So it's just basically like Near can create Bowen.near, it can create Sam.near, but it cannot create for example, Bowen.Google, for example. That has to be created by Google, the account Google. So that's kind of the idea. And then right now, what like usually the onboarding flow on Near is that people go and create an account through like a special smart contract deployed on the Near account that would allow you to like call that and then create a account that was like a name of your choice for you.
And do you ever run into problems with people trying to squat names or no?
Yeah, squatting names is actually not free, right? So that's one thing that deters people from doing that, because in order to like maintain an account on Near, you need to have like a storage locked for the you need to have like a balance locked for the storage of the account. So every time you create an account, you're not only just paying the transaction fee, right? You're also paying like a small amount of fee to lock the amount of the storage. Lock the token for the amount of storage that the account has. So it's actually not very doesn't make like a lot of economic sense for someone to like squatting accounts. Well, I guess if Near becomes like maybe they're betting on Near become like super popular, but
Yeah. Yeah. Okay. That makes sense. I had to ask because that was I've seen that happen with ENS names a little bit. Cool. Okay. So let's move on to a couple of other things. We'll talk through. I want to talk through the near data model because I think you guys have built some interesting things, even at like the API layer that might be interesting to talk through. And then we'll get into some interoperability and then maybe some future roadmap stuff. So what is like the near data model? How does like the data flow work for someone that's building a DApp maybe that needs to get data?
yeah, that's a good question. So obviously, there's on the basic level, there's like RPC that the node just provides, right? And then today in the near ecosystem, there are different providers, kind of data providers. So actually, Infura is one of them. They integrated near. Then obviously we have our own like RPC is provided, and then like there are a few other RPC providers. But then on top of that, I think there are some like more sophisticated data solutions, right? So for example, we have this kind of like a data in-house API that we have that allows you to do things that are more than just like what the RPC provides you, right? So what the RPC provides are pretty basic, right? You can send transactions, you can create like transaction result, you can like query some other stuff, but it's all pretty basic. If you want to do something with, let's say, like NFT or like fungible tokens, it becomes pretty cumbersome to do that, and then that's what the kind of in-house API is for.
Gotcha. Is that like you guys have a query API and enhanced API? Are those where people should
Yeah,
go to look
yeah,
for
it
this
would like
decentralized
merge
services?
together at some point. It's basically like the idea is to have like one API that provides all the data needs that people have.
Is there like a subgraph equivalent where if I have a contract that's spitting off events, I can make it easier for people to query data based on that?
Yeah, exactly. That's kind of the goal, right? You can think of the in-house API as like a custom built subgraph for near.
Gotcha. Okay. Makes sense. Makes sense. Okay, how about some of the interoperability things? So there's a couple of initiatives that enable people to build on Near in a way that they're probably used to, and then also to bridge back and forth between the EVM and Near, or at least uh, Aurora and Near. So let's talk through Aurora first, and we'll go through the Rainbow Bridge. So what is Aurora? What's unique about it? And yeah, would love to just the overview.
Yeah, Aurora is pretty much this compatibility layer between Near and Ethereum, right? And on Near, what it does is that it provides this kind of like vault or like enclave that underneath runs an EVM interpreter as a smart contract, and then people can deploy their smart contract into this vault, and then the experience is essentially the same as they were as if they were developing Ethereum. They can deploy the smart contract into this vault. The execution within this vault is synchronous because you can call the other contract that's deploying this vault, and then like underneath it just runs like one EVM interpreter is like smart contract. So it's like a two-layer virtualization. Um, and then obviously Aurora also has like a bunch of things that makes it easy for developer to interact with this thing, right? It has like relayer that make it easy for people like to send transactions because like you actually need to do some kind of conversion between like Near and then the Ethereum tokens and yeah, basically like there's some kind of conversion that's happening, but that's kind of like down through like relayers. And overall, like the experience is and the relayer pretty much provides like a Web3 the sorry, it provides just like a RPC that's like compatible with Ethereum, and then the entire experience is very much exactly the same.
Got you. Okay, so say I am like Aave, right? And I want to
Okay.
deploy on Near. They already actually might be on Aurora. I'm not sure. But let's say that they decide to deploy on
I think they
Aurora.
are. I think. Yeah, I'm not 100% sure either.
Okay, let's say they haven't yet. They're listening to this and they want to. Um, what does that look like for them? I mean, it's just literally I take my contracts, I deploy
Yep.
it on Aurora, and then
Yep.
I'm assuming that like what am I paying transaction fees therein? Am I paying it in
You're
Near?
paying ETH. Yeah, you're
You're
paying
paying in
ETH,
ETH.
and yeah, you're essentially paying ETH to the relayer. Relayer would convert that to Near, then it would send like it would pay the actual transaction. It would pay the Near transaction in Near.
Interesting. So is this then a way? I'm assuming this is then an easier way for someone, a project like Aave, or
Yeah.
maybe some other DeFi project or game, to interface with the rest of the Near community, right?
Yep.
These.
Yep.
Okay, got it. So, is this what the Rainbow Bridge enables? Is the Rainbow Bridge a bridge between Aurora and Near, or is that like between Near itself and Ethereum?
Yeah, it's actually between Near itself and Ethereum. So yeah, it's like a bi-directional bridge and runs kind of light client and smart contract on both sides. And then how it works is that essentially we're pushing like a light client blocks into both smart contract, and then you can use that to verify the transactions and state transitions.
Got it. Okay, so yeah, people are familiar with what that kind of thing looks like. But what about between Aurora and Near? Like, how would that interoperability work?
Yeah, so I think the Aurora team is actually working on making the interoperability happen between the Aurora Vault and the native Near smart contract. So essentially, they build like a solution that allows the native smart contract, a smart contract within the Ethereum, within the Aurora Vault to call a native Near smart contract, and then vice versa. I think that is still like in the works. But yeah, it's very exciting.
Yeah, that is exciting. That could be really interesting. And then, so on Aurora itself, are there performance improvements that someone could, let's say Aave or the other DeFi project example, like what kind of performance gains would they see by deploying on Aurora as opposed to another side chain or layer two in the Ethereum space?
So I think one of the nice things that Aurora has is that because it's just like a smart contracts on Near, right? It gets all the nice properties of Near. For example, very fast finality, like 2 to 3 seconds finality, and compared to Ethereum, that's like huge improvement, and also like very cheap transaction fees. I think there's like a comparison table somewhere, but I think Aurora is definitely one of the cheapest option if if someone wants to deploy on like a EVM compatible chain.
Interesting. And then on Aurora, are there like is there like a these I'm just saying to the questions that people ask, because I've been in these conversations before when you're like considering deploying on a specific network. I'm just asking basically on the
Yeah.
checklist. Is there like a block explorer equivalent for Aurora?
Yes.
I mean, I'm assuming
Yes.
Near obviously has that, but does Aurora
Yes.
have its own explorer?
Yes. Yes. It does. I think it integrated some. I think it already integrated Etherscan, if I remember correctly. But it also has this like a has its own, or maybe like some other like block explorer that's like fully Ethereum compatible. Because without that, it's actually the experience will suck, right? Because you cannot on Near what you're viewing is like some like serialized stuff that you don't actually know what's happening underneath, right? So you need like a custom explorer just for that.
Interesting. Okay, that makes sense. That's cool that that's been all set up. I feel like that's underrated. I feel like more people should know about Aurora, and
Yeah. I mean, more people, definitely more people should know about it. Yeah.
maybe this episode can help you. Maybe this episode can
Yep.
help you. Okay, I mentioned we're going to go into some roadmap stuff. There's two things that I've seen mentioned in various places throughout your docs. Both of them seem interesting to me. One of them I really am not sure about, but the other one I have some idea what it's going to be about. But meta transactions and zero knowledge light clients. Meta transactions, people in the Ethereum space, they're kind of familiar with the concept. But where is that in the roadmap? Is that like close to being available? And if so, like how will that work?
Yeah, it is actually close to being available. A lot of the implementation work on the protocol level is already done. And then we still need like relayers and then integrations with wallets and that kind of thing. And what it would enable, yeah, I think it's a huge step towards a better user experience, right? So today, like users have to have near in order to interact with any applications on near, right? So let's say someone send you 50 like USDC on near, and then you now your account that has those 50 USDC. You want to use them, but you realize, well, I don't actually have any near. How do I even I can't actually use it because I have to pay like my transaction fee, right? So the only option today is pretty much like you go and buy some near in order for you to even I don't know, transfer those like 50 USDC to somewhere else. With meta transactions, you can pay transaction fees in like any other like tokens or like even fiat if the relayer supports it, right? You can say like, I pay I have 50 USDC, right? I pay this like 0.001 USDC to this relayer, and then it will send the transaction for me, and then I can just don't have to maintain like my near balance there in order to use application. So this is especially useful for new people who are just joining the ecosystem. They may not have like a lot of near, or like they may join because like as I said, like people send them some like stable coin on near or like some other reason. But overall, like this would just be like huge improvement in experience for those users.
Yep, absolutely. That sounds really interesting. Yeah, I think, and especially, it seems like there's a fair number of games that are interested in deploying on near. That's at least what I've kind of seen. That's really helpful for game devs, because most people that are just trying to play a game, they don't want to go to Binance or Kraken or Coinbase to buy it.
Yeah, so I think what I didn't mention is that also enable the kind of subscription model, which is very commonly seen in the Web2 world, right? Like if you want to play like, let's say, a game or like use some app, you pay, let's say, like $5 per month, right? People are used to that kind of model. They understand what it's about. But then they don't necessarily understand like why I have to pay like some additional amount of money for everything I do there. So if you have meta transaction, you can literally like have this model, and then the application basically lumps the transaction fee into that cost, so that the application basically pays the cost, pays the transaction fee on behalf of the user, and then they charge the user in like this kind of subscription fee or something else.
Yeah, I think meta transactions have been somewhat overlooked by the space for a while, partially because they're so difficult to set up. But I think that for the next 10 to 20 years, I don't think we can expect, if we want to actually grow, I don't think we can expect to pass gas fees off to the end users every time for every use case. It just doesn't make sense, right? In some cases, people are used to paying an extra fee. Like with trading, people are kind of used to paying an extra fee when they trade, right? So I think it might make more sense for some DeFi applications, but for the end user payment stuff, or the even within games, people don't want to pay an extra fee, right? When you go and spend money at like a grocery store and you swipe a card, the company who you're buying something from covers the fee to the debit card, right? So I think that's something we need to consider as well. So very cool. It's on your roadmap.
Yeah, and also I would say it's not actually hard to set up, right? It's different from how the meta transaction on Ethereum works, and it's because it's implemented on the protocol level on near. Like all the applications just gets it for free. Like you don't need to do anything special to set it up.
Very interesting. So like as an application, will there like what will the DevX be for supporting that?
Nothing. Like unless so it depends, right? So if you are using like a third party relayer, then pretty much like nothing, right? Like the application itself doesn't need to care. Like users can like use like third-party relayer and then to send their transaction. The application developers can just like not care, right? But if they, let's say, they want to do like user acquisition, and then they want to, let's say, cover some of the costs for like acquiring the user, then they can have like a relayer themselves that would just like pay the transaction cost for the users.
Gotcha. I see. Okay, that's very exciting. How about zero knowledge light clients?
Yeah,
what are those
that
all
is
about?
also very interesting, right? So one problem today is that a lot of the applications and especially wallets in the blockchain ecosystem, they depend on someone to provide them with data, right? This is not just like unique problem to Near. It's also happening on like Ethereum, happening on every other blockchain. Like in order for like wallet to function, you have to get like the data from like some like RPC provider, for example, right? And then you're essentially trusting the data that they provided. They're providing you with like the right balance for like when you query like some specific account, maybe like you as like a wallet is like operating like a your own node to run to provide the data for the wallet. But anyways, it's like you're relying on some kind of RPC provider, and then you either have to kind of eat the cost and then run your own node and then to make sure the data is correct, or you're just like trusting, let's say Infura, like Alchemy or whatever that is. Um, and this is actually not great for decentralization. I believe Vitalik actually mentioned this exact point in one of his blog posts. So what the zero knowledge, or like what a light client would enable you to do is that, let's say you run like a light client as part of the wallet application, right? And then essentially you can verify every single like data that every single piece of like a query that you have, and then the answer you got. And you can not only just like trust the data that is provided to you, but you can also verify that, oh, this is indeed the correct data from blockchain, because you can just do like proofs and so on. And what the zero knowledge light client does is that it just makes this light client very, very lightweight, because you can do like recursive snarks there, and then it just like makes it very simple to maintain, and you don't have to spend like it makes it like very much feasible for you to just embed that into any like application, whether it's like wallet or some other application where like the data source is very important, and you want to make sure that you have the ability to verify that.
That's fascinating. Yeah, that is definitely a force to help preserve decentralization for sure. I think there's a risk that, we love Infura, we love Alchemy. They actually do really good work, but they, if everything is running on Alchemy or Infura,
yep.
That's kind of uncomfortably compromising on some of the ethos of the space. So I think you're right. Okay, fascinating kind of deep dive on what you guys are working on at the protocol level. How about just some more general stuff here? How do you guys approach developer experience? Right, it seems like DevX was a big focus across your docs and all of your the materials on the Near websites. How do you think about it? How do you think about API design, supporting different languages, and this whole idea of building developer communities?
Yeah, so developer experience is definitely very central to the entire Near ecosystem, right? It's not just like about any specific tools that we're building, or like any specific libraries, specific APIs. I think in order to have a great developer experience, it has to go into like every single layer of the stack, right? From the protocol up to all the way up to some like application level tooling. So for example, on the protocol level, we have those concept that makes developers' life easier, like access keys. Well, it both makes both the user life easier and also developers' life easier. And the kind of WebAssembly support makes it easy for you for us to support like a commonly used programming languages like Rust or JavaScript, and all of that. And then that is what we're doing on the protocol level. And then on the kind of SDK level, right, we have the Rust smart contract SDK, and today we also have the JavaScript SDK, and then we also have different SDK on the client side to interact with the blockchain. So there are like a whole bunch of things that we're doing, and this is just on the more like engineering side, right? And on the outside of engineering, there's like things like docs, and hackathons that we organize, events that we organize. So yeah, it's like a lot of those things that we're doing to make sure that we not only kind of strive for the best developer experience, but also we iterate on them. We talk to the community and gather feedback, and then improve the experience that we have.
Nice. And are there any particular applications or pieces of tooling that you wish developers would come in and build on Near? Do you have any requests for
Yes.
builds or projects?
So a lot, actually. So one thing is that today Near supports Rust and JavaScript, right, as programming languages for smart contract. But that's not really the limit, right? So because we support WebAssembly as runtime, essentially, like if you have any language that can be compiled to WebAssembly, then we can support that language as like a programming language for smart contract. So for example, if you want to support like C++, if you want to support like Java, that's all like possible. And people can just come in and build the SDK for them. And then on the kind of more like client side libraries, right? So today we have a JavaScript SDK or like a library to interact with the blockchain. I think we also have like a Rust one to interact with blockchain. And then people are, people. I would love to see people building, let's say, like a Kotlin SDK, so that you can use that in like a Android in mobile development, or like iOS SDK, Swift SDK, and so definitely want to see more.
Nice. So it's interesting you highlighted different languages a few times there. And it's an interesting choice to go with Wasm. I think that could open up a lot of different options and different ways developers can get involved in the ecosystem. What do you make of the whole languages space for developers? Like, do you think that a developer is best served by focusing on getting really good at building contracts in like Rust or Solidity or a specific language, or should they really aim to be polyglots with smart contracts? How do you see that? Focus or breadth?
That's a good question. I mean, if I'm kind of speaking from like a developer perspective, definitely I don't want to be restricted to like a single language, right? And also for like developer, usually it's not too difficult to learn like a new language. I mean, obviously transition from JavaScript to Rust is a bit of like a hurdle, but still I think it's like worthwhile because the more like versatile you are, the more things you can do as a developer. And there are, I think also technology develops really rapidly these days, and as a developer, I would want to stay like relevant, right? Keep up with the development of the technology itself and so on.
I think that's a good answer. Do you see any other like maybe bad advice that you think that is often given out to like early career Web3 developers? Like, is there anything that you see out there you wish people just ignored, or you think they should turn away from?
That's a good question. I haven't seen like a lot of advice specifically for Web3 developers. But I think definitely if you are like Web3 developer, I know that like a lot of the focus has been on like, maybe like understanding, like just like writing smart contract or like using some libraries and so on, right? But I think having more understanding of how the underlying blockchain works, especially the runtime part, is quite beneficial.
Go low level. Understand what's happening under the hood. I think that makes sense. Cool. Okay, so last question for me. This is a little more general, but what do you hope Near looks like in the next 5 to 10 years? What do you hope is happening on Near? How do you hope the chain has evolved? How do you hope the ecosystem has evolved? Would love to hear your thoughts.
Yeah, definitely hope that Near would get mass adoption in the next 5 to 10 years. So Ilya, our co-founder, put forward this ambitious goal of getting to 1 billion users in the next 5 years. It's definitely very ambitious, but our goal is that we're not just building technology in a vacuum, right? We want this technology to actually be useful to people, and we actually want it to make like a real impact in the real life. And in order to do that, we have to not just like build the technology itself, but actually get people to use it. So definitely, the biggest thing I want to see in the next 5 to 10 years is that billions of people start using like applications built on top of Near, become part of the ecosystem, and bring kind of the open web technology to the mass audience.
I love it. Good answer. Well, Bowen, thank you so much for coming on and for the deep dive on all things Near. I think people that listen to this are going to get a lot out of it.
Yeah, thanks a lot, Sam, for the interview.
Wonderful. Thanks again.